Get some examples about segments, raised distance, okay? Use figure 1 to answer the following questions. So for figure 1, we have line AB, and the first thing we're being asked, is segment AB the same as segment BA? That answer is going to be yes. That is because a segment has two distinct endpoints, so it does not matter which order you name them in, you just have to pick the two endpoints. Is ray AB the same as ray BA? This is going to be no. Rays extend indefinitely in just one direction, so the order you write this in is important. If I'm talking about ray AB, then I'm saying that my ray has an endpoint of A and heads towards B. And if I say ray BA, I'm saying my ray has an endpoint of B and heads towards A. So those would not be the same. Is line AB the same as line BA? That is also a yes. And that's because for a line, you just have to pick any 2 points on that line. It extends indefinitely in both directions, so the order you pick the points in does not matter. And then for part B, is the measure of AB the same as the measure of BA? That is also yes. And that's because the measure of AB and the measure of BA is just asking what the value of that segment is, what its measure is. It doesn't, when you're talking about measure, length, distance, however you want to think about it, whether you're going from left to right, right to left, down to up to down, your measurement is still going to be the same. So we're going to say, not in highlighter though, we are going to say yes for that. So for number 2, it says use figure 2 to answer the following questions. We have our line here with several different points on it. First thing I want you to do is number these points like a number line. We're going to do -2, -1, 0, 1, and 2. Part A says name the midpoint of segment RT. Segment RT, that's right here. Its midpoint is going to have to be point S because it is equidistant on either side. Right, they're both 1 unit long. You also might be asked in the homework like what coordinate represents the midpoint. So if you're asked for a coordinate, since this is a number line, it would just be a single number. It would be the coordinate 1. For part B, name 2 segments congruent to segment PR. Well, PR is 2 units long, so you could name any other segment here that's also 2 units long. For example, segment RT would work, and segment QR would work. Not QR, I'm sorry, QS. It's the wrong letter. So any other segment that's 2 units long. Part C, name the ray opposite to ray ST. Well, ray ST has an endpoint of S and heads in the direction of T. So the opposite ray is also going to have an endpoint of S, but then go in the opposite direction. And there are several different ways you could name this ray. First of all, we could call it ray SR, because it would still have to start at S and head in the direction of R. But also in that direction is Q and P. You have to remember a ray extends indefinitely in one direction. So you could pick any of those points. So alternatively, you could call this ray SQ or ray SP. It's up to you. Could you list all the numbers between 1 and 0? Between 1 and 0, there's an indefinite number of decimals. So we're going to say no for that. Is there a point on the number line for every number between 1 and 0? Now, something to keep in mind with geometry is that sometimes things could exist that just aren't labeled for you. There are an endless number of points on any given line. So the answer to this is yes. Just because not every single number is written down doesn't mean a point couldn't exist there. And then for F, is there any limit to the number of points between S and T? That's also a no. There is no limit. Given any segment, there is an indefinite number of points on it. Number 3, if the measure of AB equals the measure of BC, must point B be the midpoint of segment AC? Now with something like this, it's easy to automatically think, of course, right? If either side is equal, then B must be a midpoint. However, there's nothing here saying that points A, B, and C are collinear. This could be a situation where you have segment AB, and maybe segment AB is vertical, and maybe you have segment BC that's horizontal. They could have the same measurement, but B certainly isn't the midpoint. So this is no. And this could look like a lot of different things. I'm just giving you one example. In figure 3, segment ST is congruent to segment TU. S is the midpoint of segment RT. The measure of QU equals 120, and the measure of SU equals 50. So here's figure 3. Something I like to do, always label your picture if you're given additional information about it. So I'm going to mark segment ST and TU as congruent with my dashes. It also says S is the midpoint of segment RT, which means that's also going to be split into 2 congruent parts. So RS will also be congruent to those. The measure of QU is 120, and the measure of ST is 50. First, you're asked to find the measure of RS. So RS is just this little part here, and it happens to be congruent to all these other little segments. So there's a variety of ways you could approach this. One thing I would do, notice that the measure of SU is 50, and it's being split up congruently. So each part here would have to be 25, which means the measure of RS would also have to be 25. For the measure of RT, that's made up of 2 smaller parts that are each 25, for a total of 50. And the measure of QR, this is also similar to your segment addition postulate, except you're kind of working backwards from it. You know that the entire measure of QU is 120, and that the measure of RS is 25, and the measure of SU is 50. So what you can do here is take your total and subtract what you have so far, because measure of QR is really our only missing part. So you know you have 25 for measure of RS, measure of SU is 50, add those up, subtract it out from your total, and you should get that the measure of QR is 45. For number 5, it says M is the midpoint of segment XY. Find the measure of XY given that the measure of XM equals 3x squared minus 8x, and the measure of MY equals 6x plus 5. So in this situation, you aren't given a diagram, but you're welcome to draw one if you'd like. Sometimes you might find that helpful. So for example, you have segment XY with midpoint M. It tells you that the measure of XM is 3x squared minus 8x, and the measure of MY is 6x plus 5. Since it indicates to you that M is the midpoint, we know that either part here is congruent. And if the parts are congruent, that means they have equal measures. And if we have equal measures, we can set them equal to each other. So what we're going to do is set 3x squared minus 8x equal to 6x plus 5. Because if we have to find the measure of segment XY, we're going to need to find out what x is first. So that's where we're headed with this part. So we need to figure out what x is so we can plug it back in and find our total. You might recognize this from the algebra review. This is a quadratic. That means it's either factorable or you could use the quadratic formula. First thing we need to do is get this in standard form and have it be set equal to 0. So I'm going to have 3x squared. I'm going to subtract my 6x over to give me negative 14x. And I'm going to subtract my 5 over to give me a negative 5. So I now have 3x squared minus 14x minus 5 equals 0. This is factorable, so I'm going to get my two sets of parentheses. 3x squared would have to be split up as 3x and x, and 5 is going to have to be 5 and 1. The question is, where does the 5 go and where does the 1 go? Well, in order to make a 14 in the middle, you're going to have to pair the 1 with the 3x and the 5 with the x. The reason that is if you started to FOIL this out again, 3x times 5 is going to be 15x. 1 times x is going to be 1x. That could give you a negative 14x in the middle if you pick the signs properly. So to get that negative 14, that means our 1 is going to have to be positive and our 5 is going to be negative. Then to get what x finally equals, set these equal to 0. 3x plus 1 equals 0, and x minus 5 equals 0. So 3x equals negative 1, and x equals negative 1/3. I recommend leaving that as a fraction because the decimal would need to be rounded. And then add your 5 over here, and you should also get 5. So this potentially has two answers. But measurement can't be negative, so it's going to be important that when you plug this back in, it gives you a positive answer. It's easy to just automatically dismiss the negative 1/3 thinking, oh, it's negative, it can't work. But when you plug negative 1/3 back in here, it does become positive. I'm not going to write out all the math for this. I recommend trying it out on your paper because you will be expected to do this on tests and quizzes. But if you plug a negative 1/3 back in here, and I'll color code this for you. So if we plug back in our negative 1/3 for the measure of xm, you're going to get a positive 3. One second. Sorry, my stylus went a little crazy. Okay. So you're going to get 3. And then if you plug it back into the measure of my, you're also going to get 3. Then this is the segment addition postulate. You have to add your parts to get your whole. So in this situation, the measure of xy would equal 6. Then for the other one, let's try out 5 and see what happens. So if you plug 5 back into the measure of xm, you're going to get 35. And if you plug it back into the measure of my, you're also going to get 35. Now keep in mind it's essential that you get the same measure for both, since m was the midpoint. And then if we use our segment addition postulate here, the entire measurement xy should be 70. So both of these are appropriate answers in this situation. And then last one. So draw your segment AC. Point B is going to be somewhere between. We're going to see if it's the midpoint or not. We're not sure yet. It tells you the measure of AB is x plus 5, and the measure of BC is 2x minus 3. And we know our entire segment is 20. So we're going to apply our segment addition postulate and say x plus 5 plus 2x minus 3 equals 20. Combine your like terms. 3x plus 2 equals 20. Subtract your 20. 3x equals 18. And divide to get that x equals 6. So that is one part of our answer. Then we do have to find the measures of AB and BC to determine if B is the midpoint. If B is the midpoint, they're going to be equivalent, so we need to find that out. So let's plug this back into the measure of AB. That's going to be 6 plus 5, which will give us 11. And for the measure of BC, that's going to be 2 times 6 minus 3, which is going to give us a measure of 9. And those are certainly not equivalent. which means that B is not the midpoint of segment AC. Need my segment bar. There we go, segment AC. And now in the next set, we're going to look at 1.4.